All right, so here is the mild page. So please watch this because the ones that I was able to look at, I'll see if I can finish them, but there was still a lot of issues. Okay, so you need to watch these, please, and check yours, okay? All right, so the first thing you want to do is write the math model. Okay, so I would choose 2 points. Okay, so I would probably choose 0, 10. Looks like a nice clean point, and I don't know, what's another good one? Like that one looks pretty good. That one's almost pretty good. It's not perfect, but it's okay. All right, so you might choose, this is 845, or this one looks like it's 12, 14, 16, almost 1680. Okay, so something like that, right? And as long as you show me, the points, then it's fine. Okay, I just need to see what the points are, okay? All right, so you're gonna calculate the slope, okay? Remember, so you're gonna use rise over run, okay? And I'm just going to use these 2 points, all right, even though it's not perfect. But so it's going to be 80 meters minus 10 meters over 16 seconds minus 0 seconds, okay, right? Because this is my x1, y1, x2, y2. All right, and then that's going to be 70 over 16, which I'm going to put into a decimal, 70 divided by 16, which is about 4.4. Okay, so you should have gotten something close to that. Okay, if you use the other one, let's see, 35 over 8. Yeah, it was about the same. Okay, all right, so it should be around that. All right, so that's your velocity. So remember, when you're writing the math model, you're going to first write xf, okay, and then your velocity is going to go here. Time is a variable, and then your y-intercept is going to go here. All right, so these are the variables, and these always stay like this. And then you're going to plug in what you found out for the velocity, which was 4.4. Okay, and then my y-intercept right here where it crosses is 10 meters. Okay, so check the units. This should be meters per second. This should be meters. All right. Okay, all right, so state the slope as a for every sentence. So if I have this as my speed or my velocity, okay, that is the same as 4.4 meters in 1 second. Okay, so I would say for every 1 second, the position increases because it's going up. I mean, it's going in a positive direction, 4.4 meters. Okay, don't say 70 and 16. Don't say any of this. Use the actual slope that you have. It should be for every 1 second is how it should look at the start. Okay, all right. What is the position of the object at time equals 6 seconds? So we're getting a little confused about what position means versus how far does it go. Okay, so 2, 4, 6 seconds. If it asks for the position, I'm merely just reading that off. Okay, right? So 6 seconds here is 35 meters. That's the position. Okay. And how far did it move in the first 10 seconds? Explain how you know. Okay, well, if I know it's going 44 meters every 1 second, okay, in 10 seconds, it's going to go 10 times that, or 44 meters, roughly. Okay, all right, 44 meters. All right, another way you can do is you can just look at the graph. So in the first 10 seconds, all right, let me pick another color, green, I guess. Okay, so see here, this is at about 50, I don't know, 3 or 54, right? Because it's a little bit under, and it started at 10 meters, okay? So here, 10 to 54, that's also 44 meters, okay? Or you might read it slightly different, okay? So I can just look from 10 up or in a positive direction to here is 54, right? So that has gone 44 meters, okay? So you can either look at the graph, all right, or you can look at, you can, calculate it how far it went. Okay, so notice this says how far. That's the displacement. That's not the position. Okay, the position is 54, right? The position I just read off of here. How far did it go? I want the difference from where it started and ended. Okay, all right, so let's try another one. All right, so same thing. We're going to look for some points. So here's a nice clean one, 0, 60. Okay. And then you can pick another one. None of these look super clear. Okay, I'd probably just pick this one here, right? Because that looks like it's at 5.5 and 0. Okay, so y2 minus y1 over x2 minus x1. Okay, and listen, if you can't find the slope from the line, you need to Google like videos about how to find the slope, all right? Or get some extra help from your math teacher maybe, okay? Because this one, I'm expecting by now we should be able to do this, okay? So y2 is 0 minus x2 is 60, okay? Or sorry, y2 is 0, y1 is 60, x2 is 5.5, x1 is 0. Okay, so that's going to be negative 60 meters in 5.5 seconds. But again, we want to make this into a decimal, okay, because that's how we're going to do it. And that's going to be 10.9, negative 10.9 meters per second. You might get something like 11. I saw some 11.1s. That's fine, as long as it's in the ballpark and I can see what point you chose. Okay, so again, we're going to practice writing the equation. So xf, leave a space for the slope, t plus, plus xi. Okay, so look, this is just from your math. This is your y equals mx plus b, right? That's your b, that's your x variable, that's your slope, and that's your y variable. Okay, so negative 10.9 meters per second. Make sure you put negative. A lot of you forgot that. And then it starts at 60, and I'm going to say meters because that's on the y-axis. Okay, again, for every statement, if I have 10.9 meters in 1 second, I'm going to start out by saying for every 1 second of time that passes, the position decreases, right, because it's going in a negative direction, by 10.9 meters. Okay, and I want to say decrease now because this is a negative velocity. Okay. The position of the object at 2 seconds, right? So I'm just going to read that off at 2 seconds. That looks like it's about, let's see if that's 30, that's 35. It's about halfway. So I'm probably going to say it's about 37.5 because it looks about halfway in that box to me. Okay. And then how far did it move in the first 2 seconds, right? That's a change. Sorry, the first 4 seconds. Okay, so 4 seconds, it looks like it's right about 15. Okay, it's probably a little less than 15 or a little more. I can't see. Let me see. A little more than 15. So maybe like 16-ish. I bet somewhere around there. Okay, so 2 ways I can do it, right? I know if it's going 10.9 meters for 4 seconds, okay, it's going to be 10.9 times 4. So that's going to have gone about negative 43.6. Okay, if I calculate it, right, because it's going 10.9 meters every 1 second, but it's done that for 4 seconds. Okay, or if I know it started at 60, okay, and ended at 16. So the final position is about 16 minus 60. Okay, and then that's going to be pretty close, about negative 44, which is pretty close because we can't read it that close off the graph. Okay, so you can see it in either way. You can either look at the graph or you can actually calculate that. All right. Okay, so you need to know how to do this page. Okay, if you struggled on this page and it was kind of a mess, you need to come and get help. Okay, because we need to move along and be able to do this by now. All right, so if you did not get this, I'm going to put some more help videos on that same page in Class Kick 20. You need to watch some more and practice some more, and then maybe you need to come to office hours so we can do some more practice, all right? Because I want you to get this so we can move on.